Hi class, today we're going to talk about lesson 7.3, analyzing units. So our objectives today are we can use one or more conversion factors to solve rate problems. Well, our vocabulary for today are conversion factors, which are just used to convert units, and we have to multiply by one or more ratios of equal quantities. So let's look at our first example. Alright, so in our first example, we're going to find the appropriate factor for each conversion. We're going to convert quarts to gallons in A. So what we're going to do is we're going to write, or we first need to think of how many quarts are in a gallon. Well, what does the word quart sound like, or what words have quart in them? The word quarter sounds very similar, and there's 4 quarters in a dollar. So to me that says in 1 gallon there are 4 quarts. Now let's go meters to centimeters. Well, when we're going from meters to centimeters, let's think of another word that sounds similar to centimeters or has part of that word in it, like a centipede. Well, a centipede has 100 feet. So our first example, we're going to be finding conversion factors. We need to find the appropriate factor for each conversion. So when we convert quarts to gallons, well, let's think. What does a quart sound like? What word might have something that looks like quart in it? Well, a quarter sounds familiar. And there's 4 quarters in a dollar, or 4 quarters in a whole. So there are, in 1 gallon, 4 quarts. Now let's convert meters to centimeters. Well, centimeters, centi. There's another word that I'm thinking of that sounds like, or I think it has that word centi in it, like centipede. Well, we know a centipede has 100 legs. So let's think, wouldn't it make sense that in 1 meter that there's 100 centimeters? And let's think of another one while we're just at this. Millipedes. Millipedes have 1,000 legs, so that would mean that there's 1,000 millimeters in 1 meter. Now here's a little hint when we're doing conversion factors. So we need to introduce both the unit that we are desired in our answer, and we need to cancel out any of the original units so that our desired unit is all that remains. So let's look at our next example, example 2. Alright, so our next example is using conversion factors to solve problems. We have the average American eats 23 pounds of pizza per year. We need to find the number of ounces of pizza the average American eats per year. So let's start the problem by writing out what we know. We know that the average American eats 23 pounds of pizza in 1 year. Now we need to cancel out pounds. So we need to multiply 23 pounds over 1 year by some conversion factor that's going to cancel out the pounds label. So how many ounces are in 1 pound? Well, there's 16 ounces in 1 pound. So we'll have to put the 16 ounces in our numerator so that we can cancel out these pound labels. Now we can rewrite this as 23 times 16 ounces over 1 times 1, or just 1 year. And then 23 times 16 is going to give us 368 ounces. So that means the average American eats 368 ounces of pizza per year. That's a lot of pizza. Alright, let's move on to our next example. Alright, so our next example is a problem-solving application. We have a car traveled 990 feet down a road in 15 seconds. We need to find out how many miles per hour the car was traveling. So the first step is to understand what the problem's asking us. So in the problem, the units that were stated are in feet and seconds, but our answer wants us to put it in miles and hours. So we need to list a couple important information. So first, let's write out the idea that we know that this car was traveling 990 feet in 15 seconds. So while we're thinking of our conversion factors from feet to miles, we know that we need to get rid of the feet labels. So our feet need to be in our denominator, and our 1 mile will be in our numerator. But we need to know how many feet are in a mile. Well, that's 5,280. We also need to convert seconds. First, let's convert seconds to minutes, and then we'll convert minutes to hours. So, seconds to minutes. We started off with seconds in our denominator, so we want to put seconds in our numerator so we can cancel those labels out. So in 1 minute, there are 60 seconds. So we've got that conversion factor. Now we can go minutes to hours. Looking at the seconds to minutes conversion, minutes are in the denominator, so we need to put minutes in our numerator and hours in our denominator. Well, there's 60 minutes in an hour. So we can now move on to step 2, which is making our plan. So we could multiply each of our conversion factors separately, or we can just simplify the problem and then multiply by several of our conversion factors at one time. I like that second one. So before we move on to do that, let's do some simplifying. Can we simplify 990 over 15? Well, 15 goes into both 990 and 15. So let's simplify that. 15 goes into 990 66 times. So we have 66 feet over 15 goes into 15 1 second. 66 feet per second. Now we could take our 2 time conversion factors, the 60 seconds per minute and the 60 minutes per hour, and simplify this as well. We can cancel out the minutes, and then we can multiply 60 and 60 to find out that there are 3,600 seconds in 1 hour. Alright, now we can move on and solve it. So to solve the problem, we're going to write the 66 feet per second and multiply it by our 2 conversion factors. So when we do this, we're going to get rid of the seconds label, and we're also going to get rid of the feet label, so that when we're done, we're left with just so many miles in our numerator and so many hours in our denominator. Now we can multiply 66 by 1 and by 3,600. And then in our denominator we can go 1 times 5,280. Now, 66 times 3,600 times 1 is 237,600 600 miles in 5,280 hours. But we just want to know how fast they were going in 1 hour in a unit rate. So we can divide the 237,600 miles by 5,280. That's going to give us 45 miles per 1 hour. So how fast was the car traveling? The car was traveling 45 miles per hour. That wraps up example 3. Let's move on to our next example. So we have a physical science application. A strobe lamp can be used to measure the speed of an object. The lamp flashes every 1/1000th of a second, and a camera records the object moving 7.5 centimeters between flashes. We need to know how fast is the object moving in meters per second. So let's start by writing what we know. What we know is that the object moves 7.5 centimeters every 1/1000th of a second. Now, it might help us to get rid of that 1/1000th. So what we could do is multiply both the numerator, the 1/1000th, in our denominator, and our numerator, 7.5, by 1,000. Because we don't like having fractions inside of fractions. So that's going to give us 7,500 centimeters per every 1 second. Now we can convert the centimeters to meters. Well, we know that there are 100 centimeters in a meter, and since centimeters are in our numerator, we want the centimeters in our denominator of our conversion factor. So 1 meter over 100 centimeters. This will cancel out the centimeter labels. Now we can multiply 7,500 by 1 to get 7,500 meters over 1 times 100, or 100 seconds. We've got meters per second, which is what we were asked to convert to. Now let's just divide the 7,500 by 100. That will give us 75 meters per second. The object was moving 75 meters per second. Let's move on to our next and final example. So we have a transportation application. So the rate of 1 knot is equal to 1 nautical mile per hour. And 1 nautical mile is 1,852 meters. We need to know what is the speed in meters per second of a ship traveling at 20 knots. So what we know is that since 1 knot is 1 nautical mile per hour, then 20 knots has to be 20 nautical miles per hour. All right, now we can start setting up the units so we can obtain the meters per second. Okay, we have nautical miles over hours times we want to get rid of the nautical miles and convert it to meters. So meters over nautical miles will help us eliminate that. And we need to convert hours into seconds. We want to get rid of hours, so hours goes in our numerator, seconds in our denominator. Now we can do the conversion. We have 20 nautical miles in 1 hour. We're going to multiply that by, we were told that 1 nautical mile is 1,852 meters. Times, we know that 1 hour, from our last couple problems, we know that 1 hour has 3,600 seconds. So we can get rid of the hour label, which means in our numerator we have 2 times 1,852 meters, and in our denominator we have 3,600 seconds. So let's do some multiplication and then some division. Correction, 20 times 1,852 meters. So 20 times 1,852. That's going to give us 37,040 meters every 3,600 seconds. So now we can do the division. And because these are very big numbers, let's use our calculators. So we can estimate this, if we round it to the nearest tenth, to be about 10.3 meters per second. So the ship was traveling 10.3 meters per second. And that wraps up our lesson 7.3 on analyzing units. For the rest of the evening, I would like you to do the Your Turn problems in your guided note packets. See you later.